Alright, so in this video, we're going to be looking at problem number 24. So we have this equation, and we have to solve for the values of p that satisfy it. So let's rewrite it first. 4p plus 2 plus 8 equals 35. What I like to do is I like to get rid of all of these obstructions and put them over to the other side. I like to do that first because I don't like it when they're on the same side of the absolute values equation, because I can't produce two equations just like that when these are there. So I need to get rid of them. I don't want them. So let's subtract 8 first, both sides. This is going to give me 0, and this is going to give me 27. 27 is equal to 9 times the absolute value of 4p plus 2. What we can do is we can divide by 9 to both sides, and this cancels with this, and 27 by 9 is going to be equal to 3, 9, 18, 27. So 4p plus 2 absolute value. Now we can produce our two equations, our two separate equations. And here it's going to be 4p plus 2 is equal to positive 3, just getting rid of the absolute values. And then the second one is going to be 4p plus 2 is equal to negative of the other side. It's negative 3. So if we had like 4p plus 2 is equal to some other equation kind of thing here, then we would make the whole equation negative. So if it was like absolute value of 4p plus 2 is equal to 3p plus 5, I don't know, we would make this, of course, one equation would just be all of this but no absolute value, so no absolute value. And then this side would be 4p plus 2 is equal to the negative of the whole expression, just like that. That's what you would do here. I will be covering more problems where we might have this as an example. Not this exact problem, but this kind of a problem as an example. So look out for those. Anyway, going back to this problem, we have to solve both of this, so we can subtract by 2 and do that. Same thing. Actually, the steps are going to be the exact same for both of these. 4p is equal to 1, and this one's going to be 4p is equal to negative 5. Except we're having quite different results. So 4p is equal to 1/4 in this case, and then in this case, p is equal to negative 5/4. Now you don't have to, or you can't really blindly trust that these are true, because potentially they can be true, but potentially they can also be false because of some sort of a mistake. So, or not a mistake, but an absolute value extraneous solution. So let's plug it in and let's check with our check step. So our check step. Let's plug it in. So 9 absolute value of 4 times 1/4 plus 2 absolute value plus 8 is equal to 35. So let's try to simplify what's inside here. It's like the parentheses. We always simplify what's inside the parentheses first. So it's going to be 3, right? This becomes a 1, and then plus 2 is 3, plus 8 is equal to 35. So this is just going to be 3 because it's positive. So it's going to be 27 plus 8, 9 times 3, 35. Is this true? Yep, we actually saw that right here when we subtracted 35 from 8. We got 27, so 27 plus 8 is, of course, 35, is equal to 35. All right, let's look at another one. Let's look at the other one. So 9 absolute value of 4 times negative 5/4 plus 2 plus 8 is equal to 35. So this is going to give us, this cancels, negative 5 plus 2 is absolute value 9 plus 8 is equal to 35. Negative 5 plus 2 is negative 3. Absolute value is positive 3. 3 times 9 plus 8 is 35. Is that true? 27 plus 8 is, of course, 35. So 35 equals 35. This just used the absolute value sign. This one didn't because it was already positive. But anyway, both of these are valid solutions because we checked them and both of them work. Make sure to check because you can have extraneous solutions, but in this case we don't. So I hope you found this video helpful.